Hello बच्चों, let us see this passage type question. For a spontaneous reaction, the free energy change must be negative. Delta G is equal to delta H minus T delta S. Delta H is the enthalpy change during the reaction. T is the absolute temperature and delta S is the change in the entropy during the reaction. Consider a reaction such as the formation of an oxide M metal plus oxygen O2 gives MO metal oxide. Dioxygen is used up in the course of this reaction. Gases have a more random structure, less ordered than liquid or solids. Consequently, gases have a higher entropy than liquids and solids. In this reaction, S entropy or randomness decreases, hence delta S is negative. Thus, if the temperature is raised, then T delta S becomes more negative. Since T delta S is subtracted in the equation, then delta G becomes less negative. Thus, the free energy change increases with the increase in the temperature. The free energy changes that occurs when 1 mole of common reactant, in this case of dioxygen, is used, may be plotted graphically against temperature for a number of reactions of metals to their oxides. The following plot is called an Ellingham diagram for metal oxide. Understanding of Ellingham diagram is extremely important for the efficient extraction of metals. यहाँ पे दिया है Ellingham diagram. Ellingham diagram gives the relation between delta G naught and the temperature. ये Ellingham diagram हमें क्या देता है, हमें क्या यूज होता है, कहाँ कहाँ यूज होता है. It gives the feasibility of the reaction. Reaction होता ही नहीं होता वो बता सकता है. Feasibility of the reaction, and it gives the spontaneity of the reaction, whether the reaction is spontaneous or not, and that can be depending on the delta G naught value. If it is more negative, then more feasible and more spontaneous of the reaction. And this Ellingham diagram helps us to selection of the reducing agent. It helps in the selection of reducing agent. Okay, so now let us see the question related to this Ellingham diagram. That is, as per the Ellingham diagram of oxides, which of the following conclusion is true? Ellingham diagram के बारे में जो यहाँ पे जो 4 statements दिया है वो सही क्या है हमें बताना है. Okay, so first statement क्या दिया है? Aluminium reduces Fe2O3. Aluminium can reduces Fe2O3. Let us check this. Where is aluminium in the graph? Graph में aluminium कहाँ है हमें check करना है. Yes, we have this aluminium here. Next, iron कहाँ पे है देखो. Iron, where it is? Yes, here we have. So iron यहाँ पे है. उसके नीचे aluminium का curve है. Right? These two curves are. As aluminium is below to this, below मतलब उसका corresponding delta G value देखो 1000 किलो जॉल्स है और iron का corresponding around some 300 or 350 minus 300. So this aluminium can act as reducing agent. Yes, ये acts कर सकता है. The element which is below in the curves can act as a reducing agent for the above. So aluminium, as in the curves it is below to the iron, yes, it can act as a reducing agent for iron oxide. Yes, this reaction possible. Al2O3 and 2F. This reaction is possible. Why? Because the difference of these two, यह जो difference है ना इसका, वो बहुत negative होता है. So that is minus 1000 minus of minus 300. This value will become more negative. Minus 700 आ जाता. So means the negative means the spontaneity of the reaction. It is a spontaneous process and delta G value more negative G naught value. और नेक्स्ट स्टेटमेंट दिया है whereas MgO cannot be reduced by aluminium. Mg कहाँ है देखेंगे, दूसरा कलर यूज करती हूँ मैं, ऑब्जर्व करो लाइट ब्लू कलर. MgO cannot reduce this. मैग्नीशियम कहाँ पे है, देख मैग्नीशियम इज बिलो टू अल्यूमिनियम. यस इट कैन reduce. कहाँ तक reduce कर सकता है, ये देखो ये दो लाइन क्रॉसिंग एट दिस पॉइंट, अल्यूमिनियम का लाइन एंड मैग्नीशियम का कर्व दो भी यहाँ ए पॉइंट पे क्रॉस हो रहे हैं. दिस करस्पॉन्डिंग टेम्परेचर एक बार देखो, करस्पॉन्डिंग टेम्परेचर इज 1500 डिग्री सेल्सियस. सो 1500 डिग्री सेल्सियस के बिलो, इसके नीचे मतलब 1000 के पास और 1100 के पास ये हो सकता है. सो मैग्नीशियम can act as reducing agent for Al2O3 below 1500 degree Celsius. Above 1500 degree Celsius, ये देखो यहाँ पे लाइन क्रॉस हो रहा है ना, ये मैग्नीशियम एंड ये अल्यूमिनियम, लाइक दिस. दिस इज फॉर अल्यूमिनियम एंड ये मैग्नीशियम. ये लाइन क्रॉस हो रहा है तो 1500 के डिग्रीज के पास. सो ये लाइन अब अल्यूमिनियम का हो गया, ये मैग्नीशियम का हो गया. So above 1500 degrees Celsius, aluminum cannot be reduced by MgO at 1500 degrees Celsius. Option option A is the correct answer for this question. Hope you understood. Good luck.